Hello students, welcome back to your science class. So student, in the previous class we were talking about the colloidal solution and we have seen that what is the colloidal solution. Let me tell you about the few things about the colloidal solution. See students, in case of a solution, when we were started with the solution, we have understood the solution are the particles which basically very small and which cannot be seen with the help of the naked eyes. Reason. The reason is that these particles are generally less than 1 nanometer. Obviously, the size is really very small, so it will be quite difficult for us to see that. And in case of a colloidal solution, the range of the particle is 1 nanometer to the 100 nanometer. It is present in between to 1 nanometer to 100 nanometer. So obviously, they seem that they cannot be seen with the help of the naked eyes or even with the help of a powerful microscope. But yes, in case of a colloidal solution, we can say that yes, they cannot be seen with the naked eyes, but they can be seen with the powerful microscope. So in case of a solution, they are so small that they cannot be seen even with the help of a good microscope, with a powerful microscope. But in case of a colloidal solution, they can be seen under a powerful microscope. Colloidal, basically the particles, they are homogeneous. When you look at the solution, it seems that that it is homogeneous. The particles are homogeneous, they are uniform. But when we look it through that of the microscope, we will find that the particles are not homogeneous, but they are heterogeneous. When we left undisturbed a colloidal solution, it will not going to settle down. So settling of the particle does not occur in case of a colloidal solution. And the reason is that the particles used to show the Brownian movement. So they used to continuously interact with each other. They used to continuously collide with each other, and due to this collision, the particles do not settle down. And this is called as the Brownian motion. So we can say that the particles are what they are quite stable. So settling of the particle does not occur in the colloidal solution. Then the particles are of this range that they show the Tyndall effect. So when we passes the beam of a light through it, the particles used to scatter the light, and because of this the path is visible to us. So we can say that the particles are in such a way that the path is visible to us. Then in case of a colloidal solution, the particles cannot be separated through the process of the filtration. Obviously, with the use of a filter paper, we cannot separate the particles of the colloidal solution. So filtration process is not that good process by which the particles can be separated from each other. So they used to show the Tyndall effect, they used to show the Brownian motion, and they are generally homogeneous, but they are actually the heterogeneous. So these are some of the characteristics of that of the colloidal solution. Let us see what is a suspension. Non-homogeneous system like those obtained in group C in activity 2.2. So in case of a suspension, students, suspension is what? See, a suspension is a heterogeneous mixture in which the solute particle do not dissolve but remain suspended throughout the bulk of the medium. Even the particles of the suspension are visible to the naked eyes. So suspension is what? It is a heterogeneous mixture. Remember that. Solution, homogeneous mixture. Colloidal, it seems homogeneous but actually it is a heterogeneous. But suspension is always a heterogeneous mixture. So this is a heterogeneous mixture in which solute particles are there, and the solute particles, they actually do not dissolve, but yes, it remains suspended throughout the solution. So yes, we can say that it is present in the solution, but yeah, do not mixes with the solvent but remain suspended. Particles, the size of the particle is more than 100 nanometer, and obviously we can see it with our help of our naked eyes. That is what? It is a suspension. Now let us see what are the different properties of the suspension, students. So looking at the properties, the first property is what? Suspension is a heterogeneous mixture. Yes. It means what is a heterogeneous mixture? It means that the composition is not uniform throughout the solution. So that's why it is what? It is a heterogeneous mixture. Okay. So suspension, colloidal solution, what seems homogeneous but actually a heterogeneous. But suspension, it is a heterogeneous mixture. Second property of suspension, student. Yes. The particles of the suspension can be seen with the help of the naked eyes, and the reason is that the size of the particle, it is more than 100 nanometer, and obviously it is because of that there is no need of any powerful microscope or a microscope. We can see it with the help of our naked eyes. So we can say here that suspension, the particles of the suspension, it can be seen by the naked eye. Okay, this is about the colloidal particle. Second one, the particle of suspension scatter a beam of a light passing through it and make its path visible. So the particle of the suspension is there, it will scatter a beam of a light falling on it. Yes. Suspension, heterogeneous mixture. So the size of the particle is this much that when a beam of a light falls through it, they are able to scatter that beam of a light which is passing along it. And ultimately the scattering of the light will going to make the path visible. So this is the second property of the suspension, in which we will find that it will make the path visible to us. So suspension is also responsible for showing the Tyndall effect. What is the Tyndall effect? So when a beam of a light falls through a solution, if the particle of the solution scattered the beam of a light falling on it and making the path visible to us, such kind of a solution, such kind of a effect is called as a Tyndall effect. So colloidal solution shows the Tyndall effect, as well as suspension also shows the Tyndall effect. It also scattered the beam of a light falling on it. The solid particles settle down when suspension is left undisturbed. That is, the suspension is unstable. They can be separated from the mixture by process of filtration. And when the particles settle down, the suspension breaks and it does not scatter the light anymore. So, what happened? See, we said that the particles, when we left undisturbed, the true solution or colloidal solution, we will find that when we left undisturbed the particle, it will not going to settle down. Like if we take an example of a sugar and water. So it will be not get settled down. The particles which is present in it will not going to settle down. If we take an example of a milk or a blood, obviously the blood or the milk will not going to settle down. These consisting of a different particle, but they will not going to settle down as it is. But if we talk about the sand and water, or if we talk about a chalk powder in a water, so we will find that after a few interval of a times, the particles, they will easily get settled down. So settling of the particle will take place in case of a suspension. What does that it indicate? It indicates that the particles are what? Not stable. And in other cases, the particles are stable, like in case of a colloidal or true solution. But in case of a suspension, the particles, they used to get easily settle down when we left it undisturbed. Understood? So, this is what? This is also a property of a suspension. So, till now, student, we have understood about suspension. We have understood about the colloidal solution, as well as we have seen some of the examples of the colloid. Now let us start off the separating technique. Yes, there is a need of a separation of the component of the mixture. And there are a lot of different separating techniques are there, which with the help of which we can separate the different components present in a mixture. Let us start with the first one. How can we obtain colored component from blue or a black ink? So if suppose we are having a dye, a component of a dye which consisting of a blue or a black ink. So how can we obtain the different color component which is present in it? Now the activity is given here. Fill half a beaker with the water. Put a watch glass on the mouth of the beaker. Put few drop of ink on the watch glass. Now start heating the beaker. When we do want to hear the ink directly, you will see that the evaporation is taking place from the watch glass. Continue heating as the evaporation goes on and stop heating when do you not see any further changes on the watch glass. Observe carefully and record your observation. So this is also one of the method by which we obtain the component of a dye components which is present in a blue or black ink. So obviously you can see in the picture itself, we have taken a beaker, student, and the beaker is filled with the water, and on the beaker we had kept a watch glass which was filled with the ink. So when we heat it, what happened? The vapor start coming, because ink is what? It is a mixture of a different components in it, and all as well as it is mixed in the water. So when why we are not heating it directly? Obviously when you heat the ink directly, it will char. Okay. So what we used to do, we used to give the water bath to it. Obviously it is not a kind of a water bath. So what we can do, we can keep it on the beaker which is which consisting of the water, and when the vapor from that water will reaches to the ink, again the vapor start coming out from the ink itself, which is what? Which is the release of the water which is present in the ink itself. So yes, we will remove the ink which is present in it. So this is one of the method by which we can separate that of the component of the mixture or component of the dye in the water. Now there are different techniques, students, by which we can separate the volatile component from that of a non-volatile. Yes, volatile solvent or a volatile component which is a solvent from its non-volatile solute. Volatile and non-volatile is what? A volatile is what? Which means that which is having the very low temperature. Such kind of a component is called as a volatile. And a non-volatile which do not get even means which non-volatile is water which cannot be evaporated. So suppose you have taken the color and you mixes in the water. Like if we talk about the salt and water, so when we heat that of the salt and water or mixture of salt and water, the water being volatile, it will get evaporated. But the salt being non-volatile, it will not evaporate. So similarly in case of a ink also, the water which is present in that of the ink, it will get evaporated. But the color, the different components which is present in that of the dye, it will remain in it as it is. So obviously this is one of the method by which we can separate the volatile component from that of the non-volatile component through the process of evaporation. Okay, so this is one of the method, student. Now how can we separate cream from milk? This is also a method by which we can separate it. So nowadays we get full cream, toned, double toned variety of a milk packet in a poly bag or a tetra pack in the market. And these variety of a milk contain different amount of fat also. Yes, you have seen the full cream milk or a toned milk or a double toned milk. What does that mean? Here it is indicating about the amount of fats present in it or percentage of fats present in it. So how can we separate the fats from that of the milk? So this is through the process of a centrifugation. Centrifugation is not only used to separate the different components of the milk, but also from that of the blood. So basically it is used to make the heavy particles separate from the lighter by the process of centrifuging machine, and centrifugation is generally used for the colloidal particles. So see here, take some full cream milk in a test tube, centrifuge it by using a centrifuging machine for 2 minutes. And if a centrifuging machine is not available in the school, you can do this at home by using a milk churner used in the kitchen. If you have a milk dairy nearby, visit it and ask how they separate cream from milk and how they make cheese or paneer from the milk. So, the milk churner, basically how can we obtain the butter from that of the milk? With the help of the churner, we can separate the solid butter from that of the liquid one, and this butter will be used further. Similarly, in case of separating that of the cheese, one of them by using the milk churner, we can simply separate it. One become heavier, other become lighter. So centrifuging machine is what machine which is basically helpful in order to rotate the substances, and this will help in separating that of the different components from each other. Like in case of a blood also, student, whenever we used to go for a blood test, they used to take the blood in the test tube and keep it in the centrifuge machine. When the centrifuge machine starts rotating, and during this rotation the centrifuging machine used to combine with the heavy particles and leave that of the lighter one, and this is how we can separate that of the component from each other. So in case of a blood, student, the plasma consisting of a different proteins, so we can separate it through the process of a centrifugation. Okay, so centrifuge machine or centrifugation is one of the method of separation of the butter from that of the milk. Sometimes solid particles in a liquid are very small and pass through filter paper. For such particle, the filtration technique cannot be used for separation, and such are separated by centrifugation. The principle is that the denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. Obviously, with the help of the churner, when we used to spun it rapidly, what it will do? So it basically combine with the denser particle which is present in it. The particles used to combine with each other. It used to coagulate. So coagulation of the particle take place, which will make one of the particle denser. It means heavier, and the other one will remain as a lighter. And because of this separation, the heavy one, they used to settle down. So basically the lighter particles, due to churning, these particles used to combine with each other, and due to this the particle itself become one and heavier, and it will get settled down. So centrifuging machine or centrifugation is a method by which we can separate the heavy particle from the lighter one. So in this case we used to make the particles as a heavier so that we can use it. Now application, basically used in diagnostic laboratory for blood and urine test. So if you want to see anything in that of the urine, obviously the process of a centrifugation or centrifuging machine is used for that, by which we can separate the different components which is a part of the urine. Used in dairy and home to separate the butter from the cream. Obviously this we have seen that with the help of the churner, mother used to prepare that of the dairies in the home. Used in washing machine to squeeze out water from wet cloth. If you look into the automatic one, the basically it used to squeeze out that of the excess water which is present in that of the washing machine. So there also the process of centrifugation take place. Now you can correlate all these things with your normal life. So you will find that no, centrifugation is not a new thing, although we came to know about a new term, a new scientific term. But centrifugation is nothing, use of the churner. So when we rotate the churner, it will going to make the lighter particles to combine together and become a heavier one. Okay, so this is how we can say that it is also what? Application of the centrifugation. Okay. How can we separate a mixture of a two immiscible liquid? What is an immiscible? Immiscible liquid is that liquid which basically do not mix with each other. That is called as immiscible liquid. Let us try to understand. Let us try to separate kerosene oil from water using a separating funnel. Pour the mixture of kerosene oil and water in a separating funnel. Let it stand undisturbed for some time so that separate layer of oil and water are formed. Open the stopcock of the separating funnel and pour out the lower layer of the water carefully. Choose the stopcock of the separating funnel as the oil reaches the stopcock. So how can we use the separating funnel, student? Basically, we must know the meaning of immiscible liquids. Immiscible liquids are those which do not mix with each other, like oil and water. So suppose you have been given a mixture that is consisting of oil and water and you are set to separate them from each other. How can you separate it? With the help of the separating funnel. So this mixture will be kept into that of the separating funnel, and the mixture will be covered, the separating funnel will be covered with the stopcock. Now we will going to remove that of the, so that the stopcock will become open, and allow the mixture to settle down. Obviously you will find that the lower portion will be what? It is the heavier one, so it will be separated out first, and the rest of them will be separated as a water. So this is how we can separate the two immiscible liquid. Now let us see what are the applications. To separate mixture of oil and water, this is the first method by which we can separate the oil and water. And second one, in the extraction of iron from ore, the lighter slag is removed from the top by this method to leave the molten iron at the top in the furnace. So basically the application is what? It is that the mixture is water. It is a mixture of oil and water. That's why it is an immiscible liquid. And the second thing, that basically it is also used for the extraction of an iron from its ore, like hematite. Lighter slag is there and that will be removed from the top by the separating technique method to leave the molten iron at the bottom of the bottom in the furnace. So we must know that these are what? Application of the centrifugation. Now let us start with the how can we separate a mixture of salt and the ammonium chloride? Is it possible to separate the ammonium chloride and the salt solution? If yes, then which one? Ammonium chloride changes directly from solid to gaseous state on heating. So to separate such mixture that contain a sublimable volatile component from a non-sublimable impurity, the sublimation process is used. Basically, we can separate the process of a sublimation in which one which will get directly evolve into the gas and the other which do not. If both of them are mixed together, then they can be separated easily. For example, if we have taken ammonium chloride or naphthalene and we mix both of them together, and when we make you to stand in front of the class, obviously the student, they will find that yesterday, so we will find that the sublimable one can be easily separated, since it is what? It shows the process of a sublimation. So if we have taken the mixture of ammonium chloride and naphthalene, or a naphthalene anthracene, and when we heat it, what we will find out that they are what? They can be easily converted into the gas. So if we have taken the ammonium chloride mixes with that of the sodium chloride, how can we separate it? So when we heat it, the ammonium chloride will easily get sublime into the gases, and it can be found on the neck of the funnel. Okay, so this is how the process of the sublimation can be applied in order to separate the sublimable substances from that of the non-sublimable substance. Okay,